Hi everyone, I'm Vincent, Dampure Product Manager Crash, and I'm going to present you today with my colleague Mohan the few slides that we have prepared for the HyperWorks 2024 model setup and vehicle safety solutions. We have also put some highlights on the 2023.1 release also as part of these presentations, explicit solver interfaces and vehicle safety solutions. So here we are presenting a little bit from the 23.1 as well. So the agenda for today is the following one. So I will start first with a presentation of the new penetration check workflow. We'll go through some, let's say, key points on the explicit solver interfaces. So mainly key customer requests and key bug fixes that have been done on the last releases. And from the vehicle safety solutions, we have two new tools that have been released, the Ejection mitigation tool and the upper interior head impact tool. So starting with the new penetration check workflow. So as part of the HyperMesh 24 release, we have reworked this tool, which was from a core perspective, let's say, already very good. We have a very good coverage of all the features in terms of solver interpretations of intersections and penetration detections. But in terms of UI, as you can see on the left screen, on the left picture, we had still a very old UI. So we have reworked the UI to make it more, we have simplified the UI and the workflow in a simple guide bar, which make the first feeling more, easy to use. And the functionalities are all the same in terms of core features. There is no change in the calculation of penetrations or intersections. This is purely a UI change. The only additional improvement that we have added in this as part of this UI and workflow implementation is the part selection. So now you can select parts, HM parts, to calculate the penetrations and intersections on parts, which was not the case before. So here just a small recording showing you how the tool is, how the workflow is quite straightforward. So basically here, if you want to check the penetrations on parts, you select the part. You check, you have the penetration list with the details on bottom, and you can fix them in one click. So you see in 2 clicks, you have checked your penetrations, fixed them automatically. Okay. Of course, there are more functionalities or more options which were available before, but the basic workflow, which is checking penetrations, intersections, and fixing them automatically, is available. As part of the improvements as well, we have there is a manual fix for example, for the intersections which require manual changing from the user. So from the manual fix, the user is directly directed to the move tool, which is automatically pop up in this context, which makes also the corrections and the manual fix much more easy. So moving forward with the explicit solver interfaces improvements, I will just give you here now, let's say, a global overview on the most important items and that we have worked on as part of 23.1 and 24.0. So you see from 23.1, we have added the LS-DYNA 14 solver version support. We have worked also on important keywords updates for the 3 explicit profiles as reported by customer mainly, and also bug fixes. And as part of the 24.0, we have done a little bit more with the addition of the Radios 24 version, the PAM-Crash 23 version. We have new options for when deleting position entity to retain nodes coordinates or not. It's a pop-up window. I will come back on this one. We have improvements in the mass calculation, improvements in elements ID pool for the PAM crash interface, improvements in keyword support as well, and key customer bug fixes. Plus, at the end, also not last but not least, perform some great performance improvements for some important cases. So as part of the 23.1, I'm just putting here some of the key customer requests and improvements that have been released in this version. So we have at the beginning for all the interfaces, actually not just for the explicit interfaces, but implicit as well. As part of the mass and COGMY calculation, we now support part and parts assemblies. For the radios interface, we have put some efforts to address, say, long time requests from customers, like the ability to automatically create output blocks like TH nodes and TH airbody when creating airbody elements from the controller. The engine file assistant now allows to create H3D engine keywords automatically. In the mass calculation, we also made an improvement showing a new option to consider the lamp mass in the solver mass values. And one bad issues which was existing for a long time and finally fixed because somehow related to weird cases, but now it's fixed. It's some sets of type GR nodes which were badly exported as a GR node genie, and so breaking the models on the export. From the LS-DYNA side, in this release, we have the same improvement in the mass calculation as I have just mentioned in the radius profile. We have made some improvements also in the support of set of type collect, basically on the handling of ID parameterization and the identification of empty collect sets, and the support of the dry mapping file path on the export of the DEX. And for PAM crash in this release, we have, this is one of the key customer requests as well, find attach workflow considering the P-link elements is now working. For the HyperMesh 24 profile, we have the following important points. The first one, requested also by customers a long time ago, the ability when we delete position entity, so when position entity are used to position parts defining transformations. So when you delete a position, now you will have a message box exposed to the user asking if he wants to retain the actual node coordinates or to update the node coordinates to the initial position. So this is added in this release. We have also great performance improvements for composite support when models have a high number of laminates and plies. As part of the radius interface, here as well, performance improvements on the export process when the model has a high number of solver mass entities. We have done also multiple improvements in terms of support of submodel. Finally, and I hope this is the last mass calculation update, with an improvement for the mass calculation considering rigid body elements. So now we correctly consider the mass of the rigid body as non-structural mass. So this is now improves and gives the correct results when you calculate the masses of elements and components, and rigid body owns a mass themselves. So this is now considered as non-structural mass. For the LS-DYNA profile, an important improvement as part of the penetration check, we have the option to the feature to directly read the penetrations from the solver output files. Unfortunately, this wasn't working this wasn't correctly implemented for the LS-DYNA MPP solver output files. The problem here is that the solver LS-DYNA for MPP simulations writes out multiple output files and not a single one. So now we have the correct reading and reader process to read all the output files for MPP solutions. Same as for radios, we have also here done some important fixes in the support of include transform. The mass calculation update is the same as I previously mentioned for radios. So we consider now the mass of the rigid body element as non-structural mass correctly. And the last point for LS-DYNA was also an important request for some customers on the post-processing side to read D3 plot files which are written out by third-party products like MetapHost, Primer, and LS Prepost. So those tools allow to read the native D3 plot files from the solver, but to write out by themselves D3 plot files, which are, let's compressed, and those files were not able to be read in Hyperview before. So now this is improved, and we should be able now to read those files as well. And on the PAM crash side, we have the ID pool support, improve the ID pool support for constraint elements, so which avoid the renumbering on the import of models when you have ID clash between such elements. On the vehicle safety solution, so we have done, first of all, let me give you maybe a quick overview and recall everything what we have today as part of the vehicle safety tools. So as part of the occupant safety tools, we have, as you know, I guess, the seat mechanism or the mechanism tool. We have the dummy positioning, dummy and seat deformer functionalities, seatbelt system tool, and the airbag folding. And as part of the impact regulations tool, we have the barrier positioner, the pedestrian impact, the IP impact tool for FMVSS 201 and ETC 21. And we have now added two additional ejection mitigation tool, which covers the regulation FMVSS 226 and the interior head impact tool for the regulation FMVSS 201U added in 2024 HyperMesh version. So with those addition of those new tools, and finally, I want to recall everyone also that on the post-processing side, we have the Altair Safety Report Manager called ASRM available on the marketplace, which is today the state of the art of post-processing functionality and tools that we should offer to the customers for crash and safety post-processing and reporting. So let me give you an overview on the ejection mitigation tool, and my colleague Mohan will follow up, will continue with the interior head impact tool, which is much more complex than this one. The ejection mitigation tool, as you can see on the screen, I think you can understand what it means. So it's a regulation which is dedicated to test the head impact on the windows of the doors. Basically, it's a regulation which is used for airbag deployment assessment. Basically, when you have a curtain airbag to protect the occupant head impact. But this regulation is quite tricky in terms of marking. So the windows are divided in different zones, and you have we have to automatically detect the correct head positions as per the regulations and so on. So everything is covered automatically as part of this tool. So we calculate the so-called daylight opening offset lines, as well as the primary and secondary targets on each windows. And all the rules which are defined in the regulations are correctly considered. So-called target elimination and reorientation rules. And finally, we have the automatic positioning of the head form of the impactor, and of course the automatic export of ready-to-run solver decks. So the process that we follow in terms of workflow is the similar one as we use for all the previous tools like IP tools. So we have a workflow for the marking process where the user is, let's guided in the selection of the attributes which are requested for the marking. So you see a selection of the door, selection of the windows. Once this selection is done, the marking is performed automatically by the tool itself. And you have the target points, which are, or the target locations, which are automatically identified so that the user can move directly to the positioning. As part of the positioning and export of the deck, we have different capabilities. We support here, for example, for SDyna, include transform or a node transform. So you see the position of the head form is very fast. And more important is the export of the deck also, which takes just less than a few seconds. so that at the end you have the models ready to be submitted for simulation, as you can see here on the right screen. Presentations, the next slides for Mohan.
Hello everyone. So FMVSS 201U is the regulation for upper interior head impact. Actually the upper parts like pillars and headliners, they are tested for the head impact. There is a regulation like HICD value should be calculated, and if that exceeds 1000 value, then those parts should be redesigned for at that locations. Mainly this FMVSS 201U tool, what we have built here, does the marking. So the impact locations are calculated according to the regulation and marked. And when marking is done, also the construction points, lines, and planes for those markings can be validated, means can be seen on the screen to verify if that marking has been done correctly or not. And after the marking, one can do the automatic positioning with the headform impactor. Actually, the positioning also is a complex thing for the FMESS 20U, as one need to position on the that forehead impact zone with given horizontal and vertical angles, and also there is a calculation of move back angle. So it is a bit of a complex thing. But with the help of this tool, one can automatically position the head form, and also after the positioning, one can export the complete deck to directly run on the solver. And also there is a possibility to position the head form with the manual positioning. Means if with the help of regulation, if the angles are not made correctly, but even though user need want to position it and calculate that area with the simulation, so one can also position manually. And also when we go through the complete process, there are many selections one need to make, and also there are some definitions. Those will be repetitive process every time. So there is also possibility one can retrieve those, I mean save and retrieve those files. One can automate that process also. Uh, so I will represent this with one video file. From the ribbon, safety ribbon, one can take this UI marking. First of all, so this model is cut model and just a representation. And there are, first of all, you can define the SGRP, sitting reference points, front and rear. And with the guide bar, one can go through the other selections like exterior parts and interior parts. So interior parts mainly here are the pillars and the headliner and the windshield. And then after one user selects the pillars one by one, and also with each pillars there are with the regulation there are some points like AP1, AP2, AP3, and there need to be some selections to be done from user end. After the selection is done, one can hit the mark button, and after the marking, how the marking has been done, that can be seen with these construction lines or points or planes. So user can verify if it is properly done or not. So going forward, so one can select the points like B pillar and rear pillar, other points. And so for the B pillar, these some of the selections are there, like center line, highest point of door opening, uh, to mark all those points like BP1 to BP4 points. And actually, this data for the vehicle is struck data like interior parts, but only the upper surface of that parts are meshed, and the positioning, marking and positioning is done. Once the positioning is done, then with the export, one can simulate the actual deck. So here the B pillar marking and other marking has been shown. So for some of the selections like rear pillar and the front header, there are no extra selections are required. So one can just go through all this process, clicking those points, required points, and mark those. Like these are side rail points, and one can also hit mark all. And going forward, so next will be the UI, so upper interior positioning. For that, we need a head form. So that head form file will be imported. So basically, the head form file will be like this head form with forward for forehead impact zone, and there will be a system attached to it. And also here, one need to do the initial selections and the head and forehead areas to be selected. And this is the system attached to the head form, so with which the angles will be calculated. And then user needs to select the design points to which it has to be positioned. So when user hits the position button, then there will be a micro dialog will be opened showing the points which are automatically positioned. Suppose AP3 is automatically positioned, so this auto button will be shown on. And there are also some selections below to do the manual positioning also. So we'll just go through this process. And you can see the head form is properly positioned at the location. So um, without any intersections or penetrations. So that is the main thing. And there are some defined angles in the regulation under which it should be positioned. If those are not met, then the automatic positioning will not work. For example, here it is not auto positioned because the angles are not met. So one can position manually with given other buttons like rotate head form or translate in short direction. One can look if there how much penetration is there, and also the forehead impact zone node selections can be varied. One can manually rotate the head form, and if all the conditions are met, one can hit the store position button. So here in the structural property of that point, one can see what are the angles and what is the move back angle we have got. So these auto positioned positions and the positions which have been stored manually, that can be exported. So for the export, same like ejection mitigation tool, the export parameters one can define there, like the main file and other control files to the main file, and one can define the head form file there and the output directory. And nodal transform or the include transform can be used for the LS Dyna. And for radius also there is a submodel or the GR node can be exported. And for PAM crash, it is a normal group entity will be with the transformation card can be exported. Selecting the output directory and export. So for the nodal transform, one should select the head form parts which should be exported, and then all the positions will be created inside that folder with the positioning file and the FMH file. So just I will show like if we import that exported file, how it is looking. So this is the imported file with the head form positioned properly. So this deck can be exported means directly solver run can be given. This is just another example for the rear pillar, what we have positioned manually. And there is also possibility to include transform. So same thing will happen, just the include will be referred there. So for this export, directly the export will happen, no need to select anything. So one can see the complete process is very fast, automatic, and uh, there is no much of headache of looking at the regulation and checking all the things.